Hello everyone. So today we'll be presenting you about the project that we've done as a part of academic. So that is titled as Water Consumption Analysis and Prediction. Our group number is 17 and we were supervised under Dr. Owen Whelan. And so we were four of us in a team, and that is myself, Mr. Ramesh, and Tan, Raj, Rajat, and Vishnu. So each of us have contributions to this project. Now we shall be presenting you about the project introduction, about the outline of this presentation. So the outline of the presentation is as follows. So we shall be starting with the introduction, and then we shall discuss about the aim and the motivation of the project, and then the outlining of the problem which we have done as a project, and then we shall discuss about the project work breakdown, like how we've categorized our project into different parts, and then we shall be talking about the data cleaning which we have done using the CRISP-BM methodology, and then we shall be discussing about the challenges faced that we have done in the project, and we went through a lot of challenges that has to be overcome, and then we have done the data and visual analysis on the water consumption, and we shall be explaining about you even about that, and then we shall talk about the analysis of the water supply, and how what is actually affecting the water supply. For example, it might be weather or number of students, or it might be the rainfall data. And then we have built a prediction model. So we have integrated the prediction model along with the Shiny app, so that we can host the website where you can just go to the website and key in the inputs, and it will tell you what might be the water consumption that might be in the future years, and all the variables can be put in there. So we shall look into it as my friends will be discussing about it. And now, introduction. So now, talking about the introduction, it was very difficult for us to shortlist the topic. We had several ideas, as we were four different people in the group, and we had a lot of ideas to be discussed. And we came up with a final conclusion that we should do something about the environment. And then we found out that in the newspaper that there is water consumption crisis, and we thought this would be a potential project which would help in the environmental cause and as well as the university. So when we went through few facts, and we got to know a fact that there is 1.6 million liters of water, drinking water, being produced every day by Ireland, out of which half are being lost. So there is no proper utilization of drinking water, is what we felt. So this drive us to take up this project, that is water consumption analysis and prediction. We just wanted to know where the water is being used more, and how can we preserve it more. And we just wanted to make sure that what might be the future consumption, which would help us to know like how we have to manage water, everything. And luckily we were when we were searching for the data set, and we found in Google that there is a data set available for NUIG, because the smart meters has been installed by Dr. Owen Clifford, who works in the engineering department. We got to know that there is a water meters installed, and we got in touch with our supervisor Owen Whelan to discuss about this, and Owen Whelan guided us to, or may bridge the gap between us and the Owen Clifford. So we had a meeting, several meetings with Owen Clifford, as to understand where the meters has been installed. We got to know that the meters has been installed in the engineering building, and we were given three different data sets, that is main water supply, cold water supply, and RWP, which is a washroom data set water. And what is the aim of the project? To discuss about the aim of the project, our motivation and aim was to create a model which will predict the water consumption for the future years, where we consider the various variables that is affecting the water consumption. And we had proper guidance from Dr. Owen Clifford, who had done basic analysis on the water consumption, and he had shared his valuable knowledge with us. So this helped us to mm, build a prediction model. And now I shall hand it over to Mr. Rajat, who will discuss about the outline of the problem and the work breakdown structure. Thank you.
Thank you, Nishchal, for briefing us with the project. Now I'm going to take over, and the first topic we are going to talk about is the outline of the problem. The objective of this project was to analyze and determine the water consumption of the buildings in NUI Galway so as to use water effectively and possibly anticipate water scarcity and take respective measures to address this issue. So, using the information from NUI Galway water supply readings, we came up with these four outlines of the problem. First is, what is current supply and demand inferred from the engineering building? Second would be, which period of the year the building utilizes greater amounts of water? And third would be, what are the possible factors or variables that affect the water consumption? And using this information, we intend to build a predictive model to predict the water consumption for a building located inside the campus. Now, talking about the project work breakdown structure, our project water consumption analysis could be divided into five major phases. The first phase was the project initiation, which included activities like formulating the team, getting to know each other's strengths and weaknesses, and working on them. The second was the project planning phase. In the project planning phase, we held group meetings, constructed and consolidated ideas, profoundly analyzed the topics considered, and finally we moved to project execution after that. In the project execution phase, we kicked off project group meetings according to each other's schedule. We structured the documents. We aggregated individual contributions into the one single project. We aligned and structured the document, and we presented the prepared report to ON. Later, we also had the project control phase where we were in the project management. We had status meetings according to the progress of the project, and we had risk management. And the last phase was the project implementation phase, where we reviewed the code according to the industry standard. We prepared the final reports according to the format given to us, and we prepared for the online presentation, and we finally submitted the documents. Next, we are going to talk about the methodology followed by us. For gaining in-depth insight and understanding of our datasets, we used CRISP-DM methodology for data understanding. This phase helped us in familiarizing with the data, analyzing the variables in our dataset, and assessing the quality of our dataset. The first step was data understanding. So we had four main datasets provided to us, which were main water supply, cold water supply, rainwater supply, and flush water. They had various variables like time and date, the hourly rate, the hour, the date, the weekday, and what term is it, like whether it is summer, Christmas, semester 1 or semester 2. So after going through our data, we started preparing it to make it fit enough to run our analysis. We figured out that there were some missing values for particular date and hours in the dataset, for which we defaulted the values to 0. Later, we created a pivot table to analyze the consumption of water based on months, after which the variables that affect the water consumption were determined, which might be the number of students and staff, mean temperature, and rainfall data. It was a crucial step to determine the variables according to the problem statements defined and to develop the required model. We used Excel for reviewing the initial data quality issues, after which we moved to the evaluation phase. We realized that we needed a UI for our model so that the user could enter the value of variables according to themselves and the model to be able to predict the water consumption according to those values. So we used the Shiny app package available in R to develop the UI. Now Vishnu would like to continue with the presentation. Thank you.
Hi, my name is Vishnu, and I will be presenting over here the analysis that we've done on the water data set that we have with respect to two different meter readings. One is the cold water supply meter reading, and the other is the main water supply meter reading. So let me just go through the slides and give you a better representation. So yes, the analysis of MWS water data. This is the main water supply meter reading that we've actually taken into consideration. And the dataset which we had actually consisted of several factors like the volume of the consumption of water in cubic meters and with respect to different months and over different periods of the semesters. So what we can see over here in the graph is that there is a very high consumption of water at a period of the fourth and fifth months. If you could see over here, you can see that, I'm sorry. Yeah, you can see over here that there is a very high significant consumption over here on the fourth and the fifth month, and then there is a there is another significance over here in the eighth month and on the ninth month. So this graph actually gives a various. This graph actually helps in identifying the overall consumption of water in cubic meters in different months, and gives us a clear picture of how exactly our analysis has to be performed. So considering this, let me just go through the code which we have used to present this model. So we have actually applied, if you could see over here, this is actually the main water consumption analysis that we have done. And here is what, yeah, we have actually made use of ggplot over here to present the graph, which is in a more professional way. So we have scaled down the values in a particular range, which is visible over here. And the respective graph is what we actually see. And then we have segregated the years into 2012 to 2015. So the data set which we had was ranging from 2012 to 2015. So we separated it into 4 different sections, and we plotted individual graphs, which is a Q plot, and then we saw the relationship between the consumption in different years so that we could get a more segregated information about the consumption in different years. So that is what has been done over here. And then we have accumulated all the graphs that we have taken in with the help of a functionality called as ggArrange, which is in R. I'll just give you a sample representation of that. So yeah, so this is how we could actually see a combined graph of all the consumptions with the respective years. So this actually gives a clear picture of how far the water consumption or the range of the volumes of water that has been used in different years has been depicted over here. So so thereafter, we have actually focused on figuring out the correlation between different factors under consideration. So the main intention of this analysis was to figure out whether there was a significant relationship between temperature and the rainfall for the consumption of water with respect to the engineering building. So and we wanted to develop a more generic model so that this could be applied to any other buildings within the campus. So yeah, the conditional plot over here, as you can see, that there is it's a co-plot. So we have segregated the years from 2012 to 2015, and then developed certain co-plots, which is described over here in the PPT as well. So if I just navigate to that, yeah. So this is what you can see. Let me just enhance it. Yeah, this is the conditional plot, which is with respect to the main water supply meter reading. So you can see that this is actually from 2012 to 2015. Yeah, so this actually gives a better representation, or it is actually a subset of the months and the volume data set that has been considered. So it gives how far the consumption has been changing, or does it have a linear relationship, or is it has it got a non-linear relationship? So we can easily understand how this has been produced over here in the graph. So this actually gives a clear picture of how the consumption is going throughout the years. So it's a combined graph. And now the next task for us was to figure out the correlation between several factors under consideration. And the major factors under consideration was the mean temperature and the rain data, which we had with respect to the consumption of the water. So we actually tried to figure this out with the help of a correlogram, which is what you see over here in the graph. So we developed a correlation matrix, and then with the help of let me just show you the code that we use for that. Yeah. So this is what we have done. We developed a correlation matrix, as you can see, and then we segregated the core values over here. And here after that, we used chart.correlation, which is coming under the package of, if you could just go above, you can see that this is the package which has been used, performance analytics, which is used to plot the core plot. So that actually gives a correlogram, which actually gives a significance. So here, the blue symbols over here represents that there is a very high significance, and this indicates that the mean temperature as well as the volume and the rain as well as the consumption of the volume of the water has got a very high statistical significance. And this actually would help a lot in enhancing the analysis. Thank you.
While finalizing the predictive model, we had a discussion to create a tool that uses a predictive model to predict future water consumption at National University of Ireland, Galway. At first thought, we decided to implement the functionality using Microsoft Excel, and while working on it, we found an alternative solution that could be implemented using R. So R provides an imminent package called Shiny, which could aid in integrating the model developed with a web page. Shiny script app.r has three components. So a sample script looks like this, wherein you have UI written on top. So under UI, we give the commands that control the layout and appearance of the app. For example, we give tags, header 1, header 2, and the numeric input values for occupancy, and slider input value for forecasted temperature, so on. Next, we have something called server function. The server function is the one that contains the instructions that the system needs to build the app. So finally, we have this Shiny server command. So this combines this UI and server and builds the app. So that is how the web page is created. It is then later published via publish command available in R. So we could just click a button and the web page would be published. The web page looks exactly like this, loaded onto our server. So this is a open source website. So anybody can create a website and publish it at any point of time. So in this website, we can just given the occupancy. For example, I have given 10,000 students for the next January, and let us give some other value like 20,000 for February. And temperature I'll set around 5 degrees in January and 10 for February. And rainfall, let it be 110 and 120. When we click on predict, the values values in the background is applied to the model and the output is displayed in tabular format. So these values are the water that the tool has given as an output, and these values are in cubic meters. So we can use these values to effectively use water rather than wasting water at any point of time. So this is one such functionality we implemented successfully, and we have published this website too in this web page.